now we can start doing some math with vectors. So we learned how to add and subtract matrices. We know how to add and subtract numbers. How do we add and subtract vectors? So what you do is if you were drawing two vectors and you had a vector u and another vector v, if we added those together, it would be like placing the tail of one vector onto the head of the other vector. So sometimes we talk about the arrowhead being the head of the vector and where it started being the tail of the vector. And if you connect things head to tail, you would get to C by going to B first and then going from B to C. And that would be like adding the vectors u to v, u and v together. The result is the vector w. So when you add the green vector and the red vector together there, you would get the black vector. And the idea is as follows. If you wanted to get to A to C, you could go there directly. That would be vector w. Or you could go there by going vector u first and then vector v. You would still get to point C. Vectors aren't necessarily concerned about what's the fastest route to get there or how you got there. They're just worried about where did you start from, where did you end up. So we could say A to C is equal to A to B plus B to C. You would still get from A to C either way. We call the answer that we got from adding A to B and B to C together the resultant. So if A to B is equal to the vector u, then B to A, that's the same direction but in the opposite, it's the same length but in the opposite direction, that would be negative u. So it has an opposite direction. We just show that with a negative out in front. So if A is 2, negative 1, and I'll write that out as a column vector, and B is negative 1, 3, maybe I'll change that and write that in a different color. And we draw this on our diagram here. So first of all, since we're doing a lot of works with A's and B's, I am going to draw 2, negative 1. That would be 2 starting here, 2 to the right, 1 down. This would be A. I'm not going to put the arrowhead on that yet. I'll put the arrowhead when I do some work with these. And B is negative 1. So if I start here, negative 1, oops, I'll start down here actually. Negative 1, 3. This would be B. So, whoops. There we go. They're both been cloned. So if I wanted to do A, so I'm going to take it and put it somewhere. There's A. I'm going to add the arrowhead to that because A started with an arrowhead here. B would have started with an arrowhead there. I'm going to go A, and then I'm going to add B to it. So I'm going to go to where it ended, add my arrowhead here. My resultant would be this. That's 1 to the right and 2 up. 1 to the right and 2 up. When I go to B, it says you're going to take B, negative 1, 3, and subtract A, 2, negative 1. What is that going to look like? We're going to start with B. So there's my green vector B. And I am going to subtract A. So now subtracting A will be in the same direction but with the arrowhead on the opposite end. So we need to match up heads to tails. As a result, we get this vector, which is 3 to the left and 4 up. And finally, for the last one, we want 2 b's. I'm going to start down here. 2 b's, and 2 a's. Actually, I'm going to start a little bit over. 2 b's and 2 a's. So 2 b's would be this way, and 2 a's would be this way. And we would end up here. So 2 b's, oh, those are my green ones, plus 2 a's is going to equal, well, now we're 2 to the right and 4 up. You might find yourself doing this as well. These are not fractions. Try not to put that line in between. So we can do all of our vector math by drawing things out every time. But I said that doing math with vectors was supposed to make some of the geometry and trigonometry go away. Can you look at our answers, especially using the column vectors? And can you see a way that you could do this without having to draw it out? Just add them. That sounds fairly simple. Yes. Let's just add them. We add the x coordinates and add the y coordinates. Same kind of rules, sort of like adding matrices. Add the corresponding elements. And if you had the 2 out in front, that 2 could get multiplied into both of those. So this will be -2 and 6, and this will be 4 and -2. And if you add those up, sure enough, you get 2 and 4. So adding and subtracting vectors is that simple. You just add and subtract the corresponding coordinates.
Hello.
Hello. So even in 3 dimensions, you can just add and subtract the different components. So here, if you tried to imagine drawing this out in 3 dimensions, you're first going to go 3 to the right, 1 back, and then 4 up. And then from there, you're going to go 2 to the left, nowhere back or forward, and then 3 up. Where would you end up? Trying to draw this out becomes difficult. Imagining it, even trying to imagine in 3 dimensions, becomes a little difficult. As far as the math goes, though, if you're just adding the components, 3 plus -2 is 1, -1 plus 0 is -1, and 4 plus 3 is 7, it becomes really easy to find out what the answer is. P minus half of Q, so this will be 3, -1, 4, minus, and if I cut these in half, 0, 1, and 3 halves, and subtract those, we're going to get 4, -1, and 4 minus 3 halves will be 8 halves. Sorry, 8 halves minus 3 halves, 5 halves. So now, even though we can't visualize this, the mathematics is not hard to do. And this is one of the very powerful things about working with vectors in 3 dimensions, is we can now figure out these things that otherwise are hard to hold in our head and try to visualize what's happening. So A to B is 4, 7, -3. B to C, so we imagine here's A, here's B, somewhere in 3 dimensions. Here's C, somewhere in 3 dimensions. What's A to C? We just have to go from A to B plus B to C. And if we added those, 4, 7, negative 3, plus negative 1, 2, negative 5, our resultant vector is going to be 3, 9, negative 8. I'm going to get you to try the last one. So with vector equations, it's often really helpful to draw out what you know. We're told here what A to B is, and we're told what A to C is. So if I draw that out with the heads and the tails, we want to start at B and end at C. And if those are two routes that we know, if we look at this diagram, can you see that you could get from B to C by going down to here and then over to here? Which would be going from B to A and then from A to C. Well, B to A is just the negative of A to B. So we got negative of A to B, and then add A to C, we're going to get 4, negative 2, 11. Some of you might have set this up as the following. Did anybody do it this way? A to B plus B to C is equal to A to C. And if I know that A to B is this, and it's going to equal 1, 0, 5, what would have to be in there to make it work? How many people did it that way? Kind of did it that way? And then seeing that, oh, this has to be a 4, this has to be a negative 2, and this has to be 11 in order for it to work. So I've handed out the homework. That is the end of the lesson. And yeah, here is a joke for you. I don't know if you can see it. I'll read it. He's got his hand over his eyes. Jason, what pattern did I tell you to run? You said to go 10 yards out, then 10 yards to the right. And what pattern did you run? I went 10 root 2 yards at a 45-degree angle. And are they the same thing? If you add the vectors, sure. This is football, not math class. Why do you think I rounded to 2 decimal places?